On the screen, there are two windows. The one on the right is what the player sees when they play my game of Sudoku. The window on the left shows the Visual Studio environment for writing the program. Hello, my name is Peter, sometimes known as Clown Capers. When interacting with computer apps, have you ever wondered what goes on behind the scenes? What does the code look like for the app that you're using? I'm going to demonstrate one of my programs, and I'm going to show you the code that works the magic behind the scenes. Several people over the years have expressed surprise that programming for Windows is possible, believing that it was the preserve of a small elite. That is simply not true. Using Windows Forms, it is possible to build a window interface and the background code that implements a small project, such as a game. Programs in the 80s through the 90s were DOS-based, and the user interacted with the computer via keystrokes and a monitor. I was one of many who, at the birth of the PC, taught themselves to program in Assembler, BASIC, Pascal, C, and C++. Teachers in the electronics section of the School of Electrical Engineering in TAFE were naturally poised to take on the role of educators in the newly blossoming disciplines of computer hardware and software. Towards the end of my career in TAFE, I realized that it was possible for ordinary mortals to program for Windows. And on retirement, I bought myself Microsoft's Visual Studio. I also bought Ivor Horton's book, Beginning Visual C++ 2005. To my surprise, I discovered that once one got over the hurdle of the widget-based window environment, programming for Windows is relatively straightforward. All right, so let's have a look at what I've got on the screen here. There's Windows, I've called it BehindTheScenesWindySoduku, and it's a Windows app, obviously, Windy for Windows. So that's on the right-hand side. On the left-hand side is the environment for writing the program. Now what I'll do, I'll show the, where is it? The design. This is the design. So when in the design environment, I'm allowed to select from these common control items down here in this list. I can select an item and I can plonk it down on the window, and the code for that object will then be generated for me behind the scenes. So for example, there's a button there. If I select that and then come over here, then I've just put on a button. Now, that button has properties. If I right click it and come down to the properties down here, these are the properties for that button that I've just put on this on the window. So there's quite a few features there, characteristics of the button. On this icon at the top here, this flash symbol that stands for events. If I push that, it shows the various events that are possible and are associated with this button. So the obvious one is click. I mean, I don't know about you, but I would have thought that back in the day that I would have thought that a button was just a button that you push and that was it. But there's all these different events that are associated with the button. So there's a click event. If I double click in this area here, just there, it will come up with a name incorporating the word click, and it will generate a little bit of it will generate a little bit of code, which is just a frame for me to enter code for what happens when the click is made. I won't do that now because I don't want to interfere with my program, but I'll show you in more detail. I'll just get rid of that first of all. All right, so for example, all of these buttons over here. I'll just get rid of that. All of these items on the window are selected from the controls. So each of these cells here, all through there, there's 81 of them. They allow the game of Sudoku over here to be played. Now each cell has to have a unique name. So they're numbered B1 through to B81. So if I go to the code, I'll show you the code now. This is the window for the code. Now I'll show you the code. Where is it there? This is the code behind the scenes. Now, there's two parts to this code. There's, just let me push this up here first of all. Just let me show you. Oh, yeah, here we go. All right, so for example, B19, the cell labeled B19, that's its name. The code associated with that button is this code here. All right, so when I put a button cell on the window, then this code is generated in the background. Now, that's not the whole of it. There's a lot more than that. If I'll go further back. Now, you see that these names are appearing over here. So B19, the one we just looked at, it appears there. And here, with this equal sign, it's being assigned a new value. So B19, that name is an object, and the object has to be instantiated, as it's called. So what happens is an object of type button is going to be created, and this is a new version of button. So this is a new instance, that's where instantiation comes from, a new instance of button, and it's being assigned the value, and that value rather is being assigned to B19. All right, but before that can happen, the button name has to be, where is it there? B19, it has to be declared. Before you can declare a variable, it has to be declared. So this statement here is declaring that B19, the name B19, is a handle to an object of type button. So that little chevron in there, that little arrow pointing upwards, represents, I call it a chevron, but it means that B19 is now the handle to an object of type button, and all the others have to be declared in much the same way. All right, so that has to be done before B19 can then be given a new value, a new instance of the type of object button. Anyway, so that's a little bit more complicated than I intended, but anyway, there you go. So the other point I wanted to make about this bit here is that as objects, as bits and pieces are added to this window, the code is written for me in the background. Now, not all the program is there. Not all the program is generated for me. All the code that implements the functionality of Sudoku, all that functionality has to be written by the programmer, in this case me. So what I'm showing you here, from up the top here, this, where is it? Yes, this region here, this pragma region down here is code that's generated by the designer. So this is the designer. The environment here is where the window is assembled. So when it's in that mode and bits and pieces are added, then it's added in this region and the code is generated. So all of this is generated by the computer. I'll go down, and all of this is generated by the computer. There's a lot of that because there's a lot of buttons. There's 81 of them. All of this, and just down here you can see this statement here. This is the end of the pragma region. In other words, all of that I've just shown you is generated when the window is created in the designer. So the rest of it is what happens when the user interfaces with the window. So, for example, if the user clicks on play and there's a new game there, then this menu strip up here comes about because I've got this menu strip one item clicked. So all of these are being declared here at this stage here. All these items I'll put up here. Group box 1. This is the whole of these together is a group box. It's a numeric up-down counter, which in the end I didn't use that. And then there's play menu item click. So when that one is clicked, that's what happens. Now, to generate the puzzle in the first place, I generated a seed for the first row. So I used a random number generator, and each cell in the first row was allocated randomly a number from 1 to 9. Obviously, no duplicates were allowed. So that's the seed. This bit of code here actually does that. It produces that row of numbers. But then, having done that, once I've got the seed for the Sudoku puzzle, I have to build the puzzle. I have to grow the puzzle, and that's what this is doing here. It's growing the rest of the puzzle. So in this case, I'll show the solution. That's the whole puzzle there. So I have to grow the puzzle from the seed. Now, the method that I use to generate the puzzle, I'm not sure whether it's the kosher way of doing it or whether it's just some way that I made up. But anyway, I wanted to mask the way that it was made. I didn't want it to be too obvious how I constructed the puzzle. And so I've got this swap columns, and I've got this swap rows, these two modules. And the idea is that it's masking, or it's trying to hide the method I used in order to generate the puzzle. Now, I'll just briefly show you that first row there. If you look at 521, then it reappears over here as 215. And 489 appears over here as 894. And 673 appears here as 736. Then if you go to the third row, the 894 of the second row appears over here as 948. The 736 of the second row appears as 367 in the third row, and the 215 of the second row appears as 152 in the third row. So now that I've told you that, now it's more obvious. But before I use this module swap column and the row swap, it would have been more obvious what I had done. So it's just my attempt to hide what's happened. Now the rest of the puzzle is generated by bringing these columns down here, one after the other, and then these columns down here, one after the other. Anyway, so that's how the puzzle is generated. So if I play a game, I'll play a game. There's a game. Now, every game that is created is not necessarily solvable. It may be that the numbers I've randomly blanked out, maybe I haven't blanked out the right numbers in order for the puzzle to be solved. Now, if that's the case, then the player will get stuck. And so to help them, I have give a hint. So if you look at the puzzle there, when I press give a hint, you'll see one of those cells will automatically fill. This one here. So that one automatically got a number 1. Now the reason it did that is because behind the scenes the solution is there, and so all I had to do was randomly select a blank cell and then put in the value. All right, so that allows the player to continue the game if they get stuck and there's no real solution. All right, now the question is this solvable? It may be that I can't solve this puzzle. So let's have a look at the solution. The solution is there, but maybe that the blanks are such that with that information I can't actually solve it. All right, so one way to think about that is, imagine that this is a puzzle from a magazine, and I've just keyed it in. All right, so if that's the case, there's no solution in the background. It has to be solved. And that's what happens when I say help to solve a user's puzzle. So a user can key in a puzzle, click on this, and it will solve the puzzle for them. Now, it may be that the user's puzzle can't be solved, in which case the player will eventually have to guess one of the cells. Now, in my case, the solution is there, but it doesn't mean to say it's necessarily solvable. So I'm going to see if it can solve. I'm going to see if it can be solved by clicking on this. And there you see that particular puzzle that generated can't actually be solved. There's these spaces. All right, so I can give a hint. That one became a 6. Now let's see if that will allow a lot more got solved then. Let's get some more help, give a hint. I didn't see it. That one there. All right, so if I get help to solve the puzzle, it solved it. Just check to see whether there's any duplicates. Sometimes if I hit the wrong buttons or something, I can get some wrong answers, but that looks okay to me. So there you go. So that's the game. I can clear the game, and if I want to enter a value, if I want to enter that value there, for example, I'll click on there and then right click it, and I have a drop down menu. If I click on that one there, it has a drop down menu showing the possible values are 4 and 8. If I click on that one there, so all the time it's showing me over here the possible values for the cell. So in this case here, it's 7, 8, 9. That one there is 1, 2, 7, 8. That one is 2, 5, 7. So that's 6 and 7. Oh, that one's got 4. Right, so it's only got one value, so that has to be 4. I'll put a 4 in there. And there it is. All right, so just get help to. I'll go to help to solve the puzzle, and there's still a few over. All right, so that particular game would require the user to get help because there's not enough information. All right, so that's it. So what I've endeavored to show you is that you can write a Windows program relatively easily if your programming experience was through the 80s and 90s, and you grew up with DOS, and you learned programming in that era, and you might have thought that there's no possibility of writing a Windows program. Well, that it simply isn't true. You can use the Visual Studio environment, You can get Visual Studio. You can get a student version of it for. Um, I think my initial version was about 136, whereas the official version was 1,300, I think, or something like that. But anyway, it was a long time ago. It was more than 20 years ago. So that's how old this program is, about 20 odd years. So anyway, you can write programs for Windows. If you've got a background in programming and you want to write a program for Windows, just get hold of Visual Studio and you'll be amazed. As I said, it's a bit of a steep learning curve. Just the window itself has a whole layer of programming, which is just another layer of complexity on top of the complexity of the what you're trying to do in your project. In this case, Sudoku. All the code for Sudoku is one thing, but the interface between the player and the computer, that's another layer of complexity on top. But as I've tried to point out, it's not that difficult because you can just point and grab hold of an icon and stick it onto the window. All right, so that was my intention to demonstrate that to you. All right, okay, see you then. Goodbye.